Hello friends, welcome back to my YouTube channel. So today's video we'll see the how to develop the flexibility matrix for the frame with respect to the coordinate. So this is the given frame. So now we'll see how to develop the flexibility matrix for this. So our first step is to make the what we have to do is redraw the diagram, and at a time we need to put only one coordinate. So let's redraw the diagram. I will show you. I will redraw the diagram now. So three diagrams will come like this. For each coordinate one diagram. So put the here coordinate, here coordinate number 1 is acting, so here coordinate number 2, and here 3, that is movement, is acting. And you all know that its intensity is 1 kilonewton, and here also 1 kilonewton, here also 1 kilonewton. This is the point A. B, give it to the name C and D. Same for this, and this also A, B, C and D. So now call it as the M1, and this is M2, M2 and M3. Moment of coordinate number 3. This is the moment of coordinate number 1, moment of coordinate number 2 and moment of coordinate number 3. Here first thing is done. We have to read out the diagram, and at a time we need to put the one coordinate. And so now what we have to do is we need to draw the unit load table. So now I will draw it. So this is our unit load table. Here member and origin limit M1, M2 and M3. So now see here. So I am not finding reactions of this. To skip this calculation, I am calculating from here to here. I am going from right side to left side. I am solving. So only to skip this calculation part. So if you want to calculate the reaction of this, then no problem. You can calculate reactions of this also, reactions of this. You need to calculate the reactions of these three. And to skip this calculation, I am calculating from the left side to right side to left side. I am calculating from here to here, anti-clockwise I am going. So no problem. If you have to calculate the reactions of this, then you need to go further from left side to right side, here to here clockwise. So only to skipping this calculation, here I am going from this side to this side, anti-clockwise. So now see, our member is, we have the how many members? 3, DC, CB and BA. So I have written here, and origin I am taking from, I am calculating from here to here. It means I am taking origin as D here. Origin for DC is D, and for CB is C, for BA is B. So limit is, see, our for DC we have the 2 meter, it means 0 to 2. For CB we have 3 meter, it means limit is 0 to 3. For BA we have the distance 4 meter, so our limit is 0 to 4. To find out the M1, see here. So for DC member, if you cut the section x-axis far away from the origin D at a distance of x, so at what distance it is, the 1 kilonewton unit load is acting 1 into x, so it is going upward, no? So for sign convention for this is upward, we need to take the positive, and similarly downward, which is moving downward, we need to take the negative. So 1 kilonewton, it is going upward, no? So we need to take the positive. So that is nothing but 1 into x. 1 into x is nothing but x. Similarly, when it comes to M2, so if we cut the section for DC, if you cut the section x-axis away from the origin D, so for all we have taken origin D, x-axis at a distance of x. So see here 1 kilonewton is acting axial to this member. So 1 into 0 becomes 0. So M2 becomes 0. Similarly for M3, see for DC member, if you cut the section x-axis far away from the origin D at a distance of s, so it is moving like this. No, it is moving clockwise, but wait, I will show. So it is moving clockwise. So you may say for clockwise reaction we need to take the positive, but so what's the effect on this member we need to see. So if it is the moment is pushing the member to the downward, so that the downward we need to take the negative for the moment which is pushing the member to downward. This moment is going downward, no, pushing this member to downward. So we need to see the what is the effect of this movement on this member. So it is moving like this, means downward. So for downward we need to take the negative. It has the negative effect on this member. So we need to take -1. So we should not see that it is clockwise or anti-clockwise. We have to see that the what is the effect of that movement on this member. So it is pushing the member downward, so that we need to take the negative. So -1. Similarly, now we'll see for the CB, we have taken origin as C. For CB, origin is C. If you cut the section x-axis far away from the origin C at a distance of x, we need to see from here to here. So 1 kilonewton. For what is the distance of 1 kilonewton from this section is this one, DC. So DC is acting perpendicular to this member. Now we need to take the distance, that is nothing but 2 meter. The perpendicular distance of the perpendicular member for this BC is, so CD, now we need to take this distance, that is nothing but 2 meter. And it is also C going upward. No, we need to take the positive. So 3. So 1 kilonewton is going upward. Now we need to take the positive, that is 1 into, so perpendicular distance of this member is this CD. It has the distance of 2 meter. So 1 into 2. We need to take the 1 into 2. Similarly for CB, for this, if you cut the section x-axis away from the origin C at a distance of x, so it is going upward. Now we need to take the positive. So 1 into at a distance of x, 1x. 1x is nothing but x. Similarly for this CB, so if you cut the section x-axis far away from the origin C like this at a distance of x, so what happens, this rotation it comes here. See, I will show here one, the movement how it transfers from here to here. For this CD, it is 1 kilonewton acting here, no, at point D. So if it comes at point D, it acts like this. If it comes here, it acts like this. And if it comes like this, it acts like this. For CB and for AB, it comes, if it transfers from here to here, it rotates like this. And if it comes from here at point A, it rotates like this. So this is how it transfers from one point to another point. So for CB, if it comes here, it comes here, it acts like this downward. Again, it is pushing the member to the downward. This movement is pushing the member to the downward. For that we need to take the negative. So intensity is 1. So -1, because it has the negative effect on this member. So we need to take the -1 again. Now we'll see for the BA. BA, we have taken the origin as B. So if you cut the section x-axis far away from the origin B at a distance of x from here to here, so the 1 kilonewton, it comes here like this. So what happens? 1 kilonewton, it is moving downward. So downward means we need to take the minus. So minus 1. So minus 1 into minus 1 into. So for this distance we need to do the x minus this much of distance, that is nothing but x minus this. For CD distance is 2 meter, now x minus 2. So x minus 2 is nothing but, if we simplify it, it will come out as x plus 2. So our x plus 2 is nothing but our this much of distance. If you minus this much of distance from this, you will get the distance, that is nothing but x minus 2. If you do x minus 2, you will get the distance, this much of distance, that is nothing but x plus 2. So we will get the distance, and that is x plus 2, x plus 2. So now for M2, if you cut the section, x-axis far away from the origin B. For BA we have taken the origin as B. So at a distance of x from here to here. So if it comes here, this 1 kilonewton, it comes here. So 1 kilonewton into the perpendicular distance of this member is, the BC is acting perpendicular to this. So 1 into this distance is nothing but 3 meter. 3 meters. So 1 into 3. So M2 will be 1 into 3 is nothing but 3. Similarly for this, if you cut the section x-axis away from the origin B at a distance of x. So here our movement, if it comes here, so for BA it comes here. So it means it is also moving downward. Downward means we need to take the minus. So minus 1. So it has a negative effect on the member. This because this movement is pushing our member to downward. So it means minus 1. So this is how we need to fill the table. So now it becomes 3 into 3 matrix. For that we need to calculate the F11, F12, F13, F21, F22, F23, F31, F32, F33. We need to calculate these all value. So now we'll see one by one how to calculate this by using this. So we have the M1, M2, M3. Now for that 3 into 3 matrix will come like this. So now we'll solve all the values. See here, this is minus 1, x minus 2. Now it becomes 2, 2 minus x. So minus x plus 2 becomes 2 minus x if you multiply minus 1 inside. So write it here, 2 minus x. Make it as 2 minus x. For M1 value will be 2 minus x. So now we'll see solve the F11. F11 is equal to, we have the formula integration of 0 to L M1 square divided by EI into dx is equal to, EI is constant, I am taking it outside, 1. So 1 divided by EI, I am taking it outside, bracket integration of our DC limit is 0 to 2, 0 to 2 limit. So integration of 0 to 2, M1 is x. So x whole square dx plus, for CB M1 is 2, integration of 0 to 3, and M1 is 2 square dx plus, for BA we have the limit 0 to 4, M1 value is 2 minus x, bracket 2 minus x into dx, 2 minus x whole square into dx, close the bracket. Now solve it by using calci. Limit is 0 to 2 into x whole square plus integration of limit is 0 to 3 into 2 bracket 2 whole square plus integration of limit is 0 to 4 0 to 4 into 2 minus x whole square 2 minus x whole square. So now solve it. Our f11 value will come out as 20. So write it here. So f11 is 20 divided by ei. Similarly, we need to find out the f22. So we need to find out the f22. For that, we have the formula f22 is equal to integration of 0 to L m2 square divided by ei into dx is equal to 1 divided by ei. I am taking outside 1 divided by ei bracket integration of for dc. We have the m2 value is 0, so I am not taking it. CB m2 value is x, limit is 0 to 3. So 0 to 3, m2 value is x. Write it here, x square into ds plus integration of for VA, limit is 0 to 4. 0 to 4. So 0 to 4, our m2 value is 3. So our m2 value is 3. So 3 square dx, close the bracket. Now solve it. Limit is 0 to 3 into x square bracket x, close the bracket, square plus integration of 0 to 4 into 3 square. So now solve it. Our f2 value will come out as 45. Write it here, 45 divided by ei. Similarly, we need to find for the f33. So f33 is equal to integration of 0 to L m3 square divided by ei into dx. Into dx is equal to 1 divided by m. I am taking outside bracket integration of. So m3, we have the for all the value -1 for DC, CB and BA. Limit for DC is 0 to 2 -1 dx plus integration of 0 to 3 -1 dx plus integration of 0 to 4 -1 dx is equal to, so close the bracket, is equal to, see here we forget to put the square here, 2 and 2, make it 2 2 2, give the square. Now solve it. Integration of 0 to 2 -1 0 to 2 -1 square plus integration of 0 to 3 -1 square plus integration of 0 to 4 into my bracket -1 square. So now solve it. Our f33 value will come out as 9. So 9 divided by ei. 9 divided by ei is for f33 value. Similarly, we need to calculate for f12 and f21. For that, we have the formula f12 is equal to f21 is equal to integration of 0 to L. Here first point is 1. Now we need to take the moment of this m1. Second point is 2. Now we need to take the moment of that m2 divided by ei. So ei, this is m2 into dx is equal to 1 divided by ei is constant. I am taking it outside bracket integration of, for member DC, m2 value is 0 into anything becomes 0, so I am not taking it. So CB is equal to, for CB we have the limit 0 to 3, so limit is 0 to 3 and m1 is 2, m2 is x, so 2 into x into dx plus integration of, for member BA we have the limit 0 to 4 into m1 is 2 minus x and m2 is 3. So m1 is 2 minus x and m2 is 3 into dx. So now we'll solve. close the bracket is equal to, now solve it by using calci. So limit integration of limit is 0 to 3 into 2 into x, 2 into x, bracket to close the bracket, again bracket x, close the bracket, plus integration of limit is 0 to 4, integration of 0 to 4 into 2 minus x into 3, 2 minus x into 3. So now solve it, our f12 value will come out as 9. So write it here, 9 divided by ei for f12 and f21. Similarly, we need to calculate for f13 and f31. So f13 is equal to f31. We have the formula integration of 0 to L. Here first point is 1. No, we need to take the moment of that m1. Second point is 3. m3 divided by ei into dx. ei into dx is equal to 1 divided by m. I am taking outside. It is constant. Into integration of, for dc we have the limit 0 to 2 and m1 value is x and m3 value is minus 1, x into minus 1 dx plus integration of limit is 0 to 3, 0 to 3, m1 is 2 and m3 is minus 1, 2 into minus 1 into dx plus integration of 0 to 4 and m1 is 2 minus x and m3 is minus 1, 2 minus x and minus 1 dx, close the bracket, is equal to, solve it, integration of 0 to 2, 0 to 2 into x, x minus 1, x, close the bracket, again bracket minus 1, close the bracket, plus integration of this one 0 to 3, 0 to 3 into 2 minus 1 is there, 2, close the bracket, again bracket minus 1, plus integration of this one, limit is 0 to 4, 0 to 4, 0 to 4 into 2 minus x into minus 1. So 2 minus x, close the bracket, minus 1. So now solve it, our f13 and f31 will come out as minus 8. So write it here, f13 is equal to f31 is equal to minus 8 divided by ei. So now similarly, we need to calculate for the f23 and 32. So for this, we have the formula f23 is equal to f32 is equal to integration of 0 to L. First point is 2 here. Moment of this we need to take m2. m2 into your first point is 3. We need to take moment of that m3 divided by ei into dx. Here into dx is equal to 1 divided by ei is constant. I am taking it outside 1. So 1 divided by ei, I will write here 1 divided by ei bracket integration of, here for remember dc m2 value is 0, 0 into anything becomes 0. So I am not taking it. For cb we have the limit 0 to 3. So 0 to 3 into m2 is x and m3 is minus 1. So x into minus 1 dx plus again integration of limit for ba is 0 to 4 and m2 is 3, m3 is minus 1, 0 to 4, m2 is 3 and m3 is minus 1 dx, close the bracket, solve it, integration of 0 to 3 into x into minus 1. So x minus 1 plus integration of 0 to 4, 0 to 4 into 3 into minus 1, 3 into minus 1. So now solve it, our f23 will come out as minus 16.5. So f23 is equal to f32 is equal to minus 16.5 divided by ei. So now we have calculated all the values. So now substitute all the value in flexibility matrix, that is delta is equal to F11. This matrix F11 value we got was 20. So 20, F12 value we got was 9. So 9, and F21 value also 9. F13 value we got was -8, and F31 value also -8. Write it here. And F22 value we got was 45, and F23 value we got was -16.5, and F32 also -16.5. Similarly for F33 we got the value 9. So 9, close the bracket, into 1 divided by E. I am taking it outside. So this is how we need to find the flexibility matrix. So I hope you all are understood. So if you like the video, like it, share it, and subscribe for the more videos. Thank you for watching.